fast and quick video for whoever is taking a limit quiz or a test, and I'm going to break down the limits on 3 cases. All right, let's start. So first, I'm going to call case 1, what I say, I'm going to call it the happy limits, okay? These limits are actually the easiest ones to do because look what's going to happen. The case 1, I call it happy limits because you're going to get something like this. For example, the limit when x is approaching -8, and then they give you the function 5x plus 12. Well, here I see that I just can go ahead and plug my value. So I do 5 times -8 plus 12. This is going to be -40 plus 12. The limit when x approaches -8, I just do -40 plus 12, which is going to be -28. Very easy, very happy to do this limit. Let's do another one. The limit when x approaches 2, and then they give you the function x plus 5 over x plus 4. Now here, I go ahead and figure it out if when I plug 2, something weird happens. Well, when I do 2 plus 5 over 2 plus 4, I look at this and I say, oh, nice, 2 plus 5 is just 7, 2 plus 4 is just 6. So basically, as you can see, case number 1, which I call the happy limits, are the limits that when you plug your number, nothing weird happens. You just get a whole number or a value. So now let's go ahead and go to case number 2. So I'm going to go ahead and do now case number 2. I call these guys case number 2. I'm going to call them the AHole Limits, and you're going to see why. It's funny, but it's a good way to remember. So let's say now that I have the limit when x approaches 8, and then I have x minus 8 over x squared minus 64. I call this the AHole limits because look what's going to happen. When I plug the 8 on the top and on the bottom, I figure it out that I'm going to get something 0 over 0. And I go, AHole limit, what can I do? Well, look what you're going to do. I see that when I plug it, I get 0 over 0, but I'm going to go ahead and factor first and figure it out if I can eliminate the discontinuity. Now, I know that x squared minus 64 is also x plus 8 times x minus 8. On the top, there's nothing I can do. But then I look at this and I say, bingo, this over this is just going to be 1. Remember, there's an invisible 1 right here. 1 over x plus 8. And I say, awesome. I actually have a hole, and that's what I call AHole limits, at x equals 8. That's going to be your hole. Because look, when I do this, I eliminate it. That doesn't mean that it goes away. That means that you have a hole at that point. But now I can find my limit when x approaches 8. Because look, 8 plus 8 is just going to be 1 over 16. Let's go ahead and do another AHole limit. So let me go ahead and erase this. And again, this is a crash review. We already went so far the happy limits, and now we are on case number 2, and let's do another one of the AHole limits. And look what's going to happen. Let's go ahead and say that we have the limit when x approaches -4, and then they have x squared plus 9x plus 20 over x plus 4. All right, when I plug the -4, I'm going to get -4 plus 4 is 0. And here I'm also going to get 0. AHole limit. Not a problem. I look at it and I say, but wait a second. Actually, I can go ahead and eliminate the discontinuity by just factoring the top and the bottom is just x plus 4. I go bye-bye, and then I have that this is just x plus 5. Well, look at this. I plug the -4. -4 plus 5 is equals to 1. Bingo. I know that I have a hole. Remember, the hole is the one that you eliminate at x equals -4, but the limit when x approaches -4 is going to be 1. Finally, let's go with case number 3, which I'm going to call case number 3 crazy limits, and you're going to see why. So now we have the last case so far, and we're gonna call this guy crazy limits. And let's understand why I wanna call it like this. Let's say that you have the limit when x approaches -3, and then on the top you have x plus 5 over x plus 3. Now here I plug my -3 plus 5, and then I plug -3 plus 3, and then I have here that this is 2 over 0. I tried to figure it out if I can factor this, but really I cannot factor it. So now I have to go to a different approach. When I have something like this, that means that I have a vertical asymptote at x equals -3. Remember, vertical asymptotes are the values that literally the function will never touch. So because I have this, that means that in my function, I go 1, 2, 3, -3 right here. Something weird is going to happen. What I'm going to do is that I'm going to figure it out if actually the limit exists. It's probably a crazy limit and probably does not exist. So look what I'm going to do. I'm going to go ahead and approach the limit from the left by plugging values. And when you do it from the left, you're going to put like a little negative on the top. What I'm going to do, when you approach from the left, you need to find a point that comes from the left, very close to x minus 3. Well, you know what? The best value and the easiest values from the left is going to be -3.01. And I'm going to plug it to see what is the closest value when x approaches -3 from the left that I'm going to get. So this is -3.01 plus 3. And when you plug this in your calculator, you get -199. That means that when the function comes from the left, it's actually going to go to the negative infinitive. It's actually going to approach negative infinitive. All right, I'm almost done. I'm going to do the same, but now with the right side. So I'm going to put a plus. From the right side, the closest value that I can, remember is -2.99. So like around, -2.99, let's see what happens here. So -2.99 plus 5 over -2.99 plus 3, and when I plug this on my calculator, I get +201. Ooh, this limit is crazy. Look at this. When I approach from the left in a really close value of the asymptote, I get a really big number. That means that you're approaching to negative infinitive. When I approach from the right, that means from a value, close to -3 from the right side, I get a positive value, really big. So that means that the function is going to go, to the infinitive. Because of this craziness, one goes negative and the other one positive, the last case is when you have a limit like this, where you have a vertical asymptote, most likely the limit does not exist. Conclusion, we have case number 1, which is the one of the happy limits, when you have a polynomial or something that does not give you a weird number. The a-holes, you're going to try to factor and figure out if you have a hole. And finally, the crazy limit, when you cannot factor and you have a vertical asymptote. I hope this crash review can help you with your quiz.